So hi, good morning. This is the Gardener community meeting. That's the first meeting this year, so Happy New Year to everybody. Today we have a packed agenda. So first, Rafael will talk about Gardener version 034 and extensions 1.2 releases overview. Then Daniel will talk about health check controllers for extensions. Then we have Tim Usner with TLS certificates for seed ingresses and cost reduction plans. And finally, Svilen will talk about ShootState sync controller. So Rafael, you can take over.
One sec, need to share. See the screen?
Yep.
Okay. So I wanted to quickly go over the release notes of the latest Gardener release and the latest extensions release. I don't have everything inside, so if you want to read the full release notes, please follow this link to GitHub. So for Gardener first, there are certain things where action is required for end users. The first thing is that we have changed some ingress host names for the logging and monitoring components. I won't say anything further because Tim will explain it later in his slot. Same for the second one. We are now deleting the Kube API server service for clusters in hibernation. Also here, Tim will explain some more. And also the third one is related to this domain change. Then this fourth topic, it may be interesting for operators, is that all the Gardener components now work with the new API group, the V1 beta version and no longer the alpha version. And that the resources that are applied to Gardener should be changed to V1 beta 1. So the alpha version will stay for some months, but will be removed eventually. Okay. And then for developers, if you check out this version, you have to rerun the dev setup script to refresh the version priority, because now beta version has a higher priority than alpha. Regarding the notable changes, we have now in this Gardener release 1.17 support for Kubernetes. And all the extension providers have also been adapted. So for all our well-known extensions that we develop in the Gardener org, 1.17 should be supported. We have made some version updates for the metric server and for the Kubernetes dashboard, which means that we now show the dashboard for 1.16 and also 1.17 clusters, which was not possible before. Then also relevant for kubectl commands, the V1 beta 1 API version has now the highest priority, as already mentioned. So yeah, you might want to adapt your kubectl commands if you need another version. Then we have removed the Calico leftovers that have been in the Gardener repository and also the machine controller manager leftovers, because they are now moved to extensions completely. So Gardener does not know anything about these two components anymore. Then the next topic is again related to Tim's slot. I won't say anything about it. Then we have made a change that gives us a little bit more observability about the extension controllers running in the seed. So far we didn't have any conditions in our seed or controller installation resources that showed whether the extension controllers are running fine or not. So we have seen cases where the extensions were, for example, crashing or not starting for whatever reason. And there was no indication other than looking directly into the cluster. And now the controller installation resources have this controller healthy condition, which reflects the health status of the extensions. And this condition is also added to the corresponding seed cluster, which will summarize these statuses for all the extensions on the seed and then have one extension ready condition, which is true if all the extensions are good. Yeah, and for shooted seeds, this is also transported to the shoot then. So in the Gardener dashboard, you will see it then directly if an extension is crashing or not running for whatever reason. The next change is that so far we have enforced end users to provide a node network sitter when a shoot is created. Now there is the possibility that this sitter is omitted in case the respective infrastructure extension creates this node network dynamically. This, for example, enables infrastructures where the sitter cannot be predefined but needs to be come up dynamically during the shoot creation. Yeah, this is basically the same release note here. The last one relevant for developers is that the extensions API now uses the V1 beta package and no longer the alpha package. Yeah. Regarding improvements, we have one experimental add-on, which is schema, which is more or less, the purpose is to give end users an easy way of installing it to try it out. But this is only time-boxed solution. Eventually, this schema add-on will be removed again and will be added to this application hub, where all the other standard temp charts will reside. So this is just to fill the gap until this hub is ready in the meantime. Then we have encryption configuration for the Gardener API server now configurable via the Helm chart. So in case an operator wants to encrypt not only secrets, but also Gardener resources, for example, controller registrations or whatever, this encryption configuration can be specified now. Then Daniel has made a change in the care controller. I also won't go into the details because he has a slot as well. Same for the next topic where Svilen will shortly present the ShootState sync controller, so I won't say anything. And for developers that are interested in adding another network extension, we now have also finally some documentation added. Are there questions to the Gardener release notes? Because otherwise I would proceed with extensions changes. And I proceed again. I have not added everything. So full release notes are available here. So for users, there are some action required for early cloud, Google, and OpenStack shoots. So we have now harmonized these worker fields. So for early cloud, they were called worker. For AWS, it was workers with an S at the end, and now it's workers for everybody. So shoot manifest should be adapted. One important thing here is that this is only usable when we have removed the old Garden subcloud.io API group, which will happen in the next release. But just that you already know that these old fields without the S will be removed in the future, and we should use the new one then. For the Helm charts, we have a breaking change. We have moved some field for the VPA now on top level. So you might want to adapt your controller registrations if you use this extensions release. And then the next two release notes here are also important, which need some manual action. Previously, we had the machine image mappings directly in the controller registration because they were part of the config of the respective extension controller. But now we have moved these mappings to the cloud profile directly so that you have one place, the cloud profile, where you define the mappings. So version to the real infrastructure specific ID. For example, in AWS, it's the AMI. And where you also define the logical mappings or the logical versions, which are then used by end users. Okay, then notable changes. There's a new feature to remove the ECR permissions that we have installed by default for the AWS role policy. It's configurable in the infrastructure config via this flag here. The default is still like it was before, so the permissions will be granted if it's not disabled. And for the OpenStack cloud profile, it's now possible to support multiple regions with the same cloud profile, even if their, for example, their keystone URLs are different. So earlier it was only possible to provide exactly one URL. But if this URL is different in another region, then you had to create another cloud profile. But now with this change, you can add this mapping of regions for these specifics. So URL, load balancer providers, and floating pools. Then improvements. Again, this is for Daniel's slot with the health checks, so I won't say anything. And the next one is that also for OpenStack cloud profiles, you can now specify regional image IDs. So earlier, you only had one global image ID that had to be accessible from all the regions. But now if you have, like similar to AWS or Ali Cloud, region-specific IDs, you can now reflect this in the configuration. Yeah, so these were the updates for the releases. I said I omitted some minor changes. Do you have questions here? Then I finish with the last section about what is next. So the first one is that we want to release Gardener 1.0. And the major change here will be the removal of our old Garden Subcloud.io API group, which is deprecated since October. And yeah, now will be finally removed. And with that, the extensibility should be also completed. There might be a few leftovers in the code here and there, like we have already removed with Calico or MCM, but the major contracts and APIs are implemented and established. Okay, after that, as I said, there are some leftover tasks now after we have worked on extensibility, the Gardenlet, and some other major contributions that we made. And we want to spend some time now to, again, improve stability, eliminate our technical debts, and also implement more tests. So there are quite some 6 or 7 topics for the Gardenlet with respect to bootstrapping, certificate rotation, how it reports its seed status, that it's still, or its heartbeats basically, high priority deployments, and hardened ABAC roles. So there's quite some work to be done. Then we have, since quite some time, also the DNS providers that are already supported in our APIs, but not, nothing is done with them except for the first one. So this should be implemented now. And yeah, I didn't list all of the issues. There are way more. Of course, we won't work on all of them, but there are a few other leftovers and so on that can be looked up in the respective repositories of Gardener or extensions. And one important one is also the last bullet point, which is splitting this large Gardener extensions repository into dedicated ones. Now that extensibility is almost completed. Then we have a team working on control plane migration, where also the ShootState sim controller is related. That will be presented soon. This will be ongoing in the next months. We have to do the CSI adaptation for the in-tree providers. We still use the in-tree volume plugin right now, but Kubernetes is planning to completely remove it with 1.2020. Yeah, I think 1.2020, 22. So we have to check what needs to be done. There are at the moment some open bugs also on Kubernetes side. For example, if you migrate to CSI, you cannot delete volumes that have been created previously, which is quite bad. So we can't migrate until these bugs are fixed. But hopefully with the next major Kubernetes 1.18 release, we can then also adapt our extensions here. Then we have some activities around the local development setup. So there is a question about kind versus Docker versus Minikube versus, again, other local Kubernetes clusters. So what we actually need for Gardener local setup is just an etcd and a kube API server. So we don't need any nodes here. So the idea is to remove these dependencies, or at least not rely on them, and also provide the possibility to simply start 2 containers, etcd and the kube API server, and work with them locally. And the second one is looking in some, doesn't have a name yet, local or mock provider, which will allow to completely set up the seed and also shoots directly on the developer machine. Right now you need some infrastructure account and some real cluster for the seed, which is not quite good. And more tests I already mentioned. So there's a PR for a new test framework. We want to work on more unit tests, also together with our leftover task that I talked already about. And there are plans to write integration tests for the new health check controllers, for the infrastructure extensions, and so on. And with extensibility, this should be now way easier than before. And then there's cost improvements where Tim will also explain what is planned here. Yeah, this would be all from my side. If there are no questions, then I would hand over to the next presenter.
Thanks, Rafael. So the next one is Daniel. Daniel, you're still muted.
You hear me now?
Yes.
Oh, perfect. Yes. Well, thanks, Rafael. As you already mentioned, I'm going to continue with the health check controllers, a part of the extensibility story. And so why do we even need these health checks for the extensions? Basically, extensions deploy dependent API resources, for instance, deployments, managed resources, daemon sets, whatever. They can deploy anything into the shoot or the seed. And they, of course, need to also make sure have a regular heartbeat interval that these components are also healthy. And then, because they are part of the shoot, they need to contribute back that health information to the shoot itself, so that the shoot knows if certain parts are not healthy anymore. For instance, if a deployment of the control plane in the shoot is down, that is deployed by the extension, then of course the control plane is not healthy anymore of the shoot. And previously, that kind of status information was not reported back. And that's a part of the extensibility story. And another benefit is, of course, that the gardener previously needed to have some cloud provider specific knowledge, for instance, about machines that the machine controller manager deploys. But actually, that is not required anymore, because that is what the provider worker controllers actually deploy. They deploy the machine controller manager, and that will deploy the machines. So we remove that indirection there. And actually, a provider can deploy any kind of machine controller. It doesn't have to be the MCN. In general, looking at one specific provider, here, for instance, for the provider AWS, it's a very general way of looking at it. It will deploy a deployment stateful sets or daemon sets, and it uses a health check library that's being introduced to perform these health checks, just to make sure that the deployment is healthy. For instance, looking at its status, making additional checks. But in general, they can make any check they want to. If they deploy very specific things, or for instance, like the Calico extensions, they can also theoretically execute network tests to make sure the network is healthy. Like, you can imagine anything there. And then once it performed these health checks, it writes certain health check conditions back to the specific extension CRDs. For instance, the worker CRD or the control plane CRD. We will look later into it in more detail. This is the common use case, just because it's also very widespread used, our managed resource. We also look at that here. A lot of extensions use managed resources to deploy their dependent API objects. And so they deploy the managed resource. The Gardener resource manager picks it up and deploys the resource to the seed or to the shoot, for instance. And the Gardener resource manager basically is also an indirection here and writing itself already basic health check conditions, the resource healthy or resource applied. So the Gardener resource manager performs its basic health checks here, and the extensions with the use of this extension health check library can already understand these conditions here of the managed resource and check if the managed resource itself is healthy and contribute that back. And eventually also writes to the worker on the control plane CRD. This is the part of the provider, the extension provider. Looking now at the full picture. Basically, what I was talking about was this part here, the extensions performing its health checks and writing it to the specific extensions. The provider extensions are writing the information to the worker CRD and the control plane CRD. The network in Calico writes its health checks conditions to the network CRD, and the shoot search service and the shoot DNS service write it back to the extension CRD. The contract here is that they are writing health check condition types that are the same in the shoot. So here on the left side, we see the types: control plane healthy, every node ready, and system components healthy. We can also see those in the Gardener dashboard. System components, nodes are ready, and control plane. Most of you, I think, are familiar with these ones. The API server readiness is not checked by the extensions because that is directly deployed by the Gardener itself. So they write these conditions back into the status of the worker, and the Gardener controller manager, more specifically the care controller, then reads those conditions from its deployed extensions and contributes that to the shoot status. Basically, it uses the health information from the extensions and mixes them together with his own performed health checks to aggregate it into an overall shoot health. And then it writes these conditions that we also see in the dashboard: the control plane healthy, every node ready, and system component healthy. Let's move to demo now, where we can see it more clearly. Basically, I have an AWS shoot here that has those health check conditions. We can see them here: API server, control, nodes, and system. And I have my seed. So I'm going to watch the workers extension now, the worker extension CRD, and we see here that it currently has these conditions of the mentioned types here, and the health checks for them were successful, as it said here. So the provider is executing health checks on them, and one of them are successful, 1 of 1. So the shoot looks all good, everything looks fine. What I'm going to do now is I'm going to delete something from the control plane of the shoot. And more specifically, the machine controller manager. And that should be realized, or that the health check should go wrong from this point on, because it sees, oh, I'm deploying a machine controller manager. It's not there anymore, the deployment. Yeah. So I deployed that. I see here now that one-of-one health checks for the worker failed, and specifically the machine controller manager cannot be found anymore. So this was already detected by the provider. Now the gardener should pick that up. As you can see here, the control plane of the shoot actually turned into progressing. We can also take a look at that. We see now that the gardener itself also reports that. So it actually read the condition from the extension, from the worker extension, and aggregates it here and displays that help information. Now, of course, we want to restore the control plane again, and we let it reconcile once so that the provider reconciles also and it redeploys the machine controller manager. It should do that now, and eventually, hopefully, we'll see here that the machine controller will be deployed again, so we can see the shoot is already reconciling. And once the machine controller manager that just popped up here is running and ready, the health check should be green again. So this condition here should be fine. That just happened now. And the control plane eventually should also turn healthy again. And of course, it depends on how the sync interval of the shoot care controller in the gardener is until it reports here. But that shouldn't take more than like 30 seconds, something like that. Yeah, now it turned healthy again. That's it for the demo. Maybe a last couple words on the library these extensions are using. Basically, they're not re-implementing these basic health checks for deployment, stateful sets, so on and so forth, again and again, but we wrote a library for that to make it more reusable. It's not so much effort in case you want to write your own provider to perform your health checks. And this is under the docs health check library, where it basically describes the goal, how to use the health check library, what needs to be done, and yeah, what it's basically doing behind the covers, and what will come next there also. Basically all that what I just showed you, and how to write the code for it to make it as easy as possible. That being said, you can always, if the library doesn't fit your needs, there are certain extension points where you can, mostly your interfaces are used, so you can override it and you can basically customize it to your own needs. That's basically it from my side. If anybody has questions, you're welcome to ask them. Yeah, does anybody have questions?
Seems not to be the case. Thank you, Daniel. Next one is Tim.
Right, thank you. Just let me share. Daniel, could you stop sharing?
Yep, 1 second.
All right, thank you. All right, so you should see my screen. Okay, so I have two topics for this community meeting. The first one is a change in the latest Gardener version, which we implemented. And so as you may know that we have certain ingresses in our shoot control plane, which are currently the alert manager if you have configured alerting for the shoot, the Prometheus for monitoring, as well as the Grafana dashboards for it, and last but not least, the Kibana dashboard for logging. And yeah, by default, all these endpoints or ingresses are served by a TLS certificate, which is signed by the cluster CA. And of course, the cluster CA is created when the shoot cluster is created by, especially for that use. And but due to that fact, the TLS certificates, which are by default used, are not globally trusted. So whenever you open the web pages of the Grafana dashboard or Kibana and so on, you will get these annoying untrusted alertings in your web browser telling you that that this issuer is not trusted, and if you really want to proceed, and it isn't really nice. So we finally decided to implement some means that you can also serve valid certificates for these endpoints. Yeah, so the basic idea is what I wanted to present to you is, for example, you have a seed cluster, which is shown here. That's the seed object, and the most important part, this is also the reason why I left out the rest of it, is the ingress domain. So the ingress domain for this seed object, here it's ingress.shoot project Gardener Cloud. And the idea is that you issue, or that you get some valid certificate, some globally trusted certificate for exactly this ingress domain. And this ingress or this certificate must be a wildcard certificate for this domain. So for example, here it's part of the common name, but it can also be an element of the subject alternative names list. And as I said, the most important part that this domain is trusted in the certificate. Okay, so this would be the first step. You acquire the certificates. And the second step is that you create a secret in this seed cluster in the garden namespace. And yeah, you label the secret by the label gardener.cloud role control plane -cert. And after the next reconciliation of the shoot cluster, the gardener picks up the secret, or the gardenlet picks up the secret and replicates the secret into each shoot namespace in this very same seed cluster. So it will end up, a copy of the secret will end up in each shoot namespace, and then the corresponding ingress objects in the shoot namespace, like the ingress for Grafana or here for Kibana, I just picked two examples, they refer to the secret, so that you can finally, or that these endpoints are finally served by this globally trusted certificate. This is the basic concept behind it. If there's no such secret found in the garden namespace, then we will always fall back to the default behavior, that is that the ingresses are served with the cluster CA signed certificates, like the case like we had it before. So this is, as I said, the basic concept, and there's also best practice for it. So as I said, you need to acquire these certificates from somewhere. Of course, you can do it manually. Depends on your your certificate provider that you're using, but the most convenient way is that your seed clusters are also shoot clusters, or that your seed cluster is an ordinary Kubernetes cluster which has some certificate management inside. For example, in our case, we have the cert management project in our seed clusters, and we can simply create a certificate custom resource, and the cert management component takes care about acquiring or requesting the necessary certificate from Let's Encrypt. And then we'll get certificates with these ingress domains, or with these wildcard domains totally automatically. And yeah, so we have a whole automation around it, and Gartner picks it up. All the endpoints are secured or served securely by these certificates. Okay, so this was the first topic. Any questions concerning this? Okay, so then let me move on to the second topic. Small topic. So Rafael already mentioned that we had some cost optimizations in the past, and that we also have have a plan for the next weeks, which we are going to approach. So the first one is we just implemented that whenever a cluster is hibernated, that we also delete the load balancer for these hibernated shoot clusters. So yeah, the implementation behind it is that every shoot cluster has a Kube API server service of type load balancer, and when the shoot is hibernated, we simply also delete the service, and when the shoot is woken up again, we create it again. There are some exceptions though. So for example, if you don't use proper DNS provider, or if your seed also doesn't use any DNS, then we'll keep this load balancer service, because we the kube configs handed out by Gartner have these backing IP addresses or domain names inside the kube config. So when we if we deleted it, we would also invalidate the kube configs, which we don't want, of course. Yeah, then there are 3 ongoing topics. So the first one of it is that we wanted to better utilize the seed machines. So yeah, we are currently analyzing some improvements there, that we can better set our requests and limits in order to improve the scheduling and the auto scaling of our seed of the seed clusters. Yeah, so that as I said, that the machines are better utilized, and of course this will eventually save a lot of money. The second topic, and work has already begun for that, is that only one load balancer is used per seed for all the control plane components, or for all the API server components that are served on that seed. So the enhancement proposal was already merged a few weeks ago, and if you're interested in that design, you can consult this link and read through the proposal. And the last topic is that also we want to have some improvements for the shoot clusters, because at the moment in every shoot cluster there must be at least one load balancer, or we place one load balancer for the VPN connection. And we finally also want to get rid of the load balancer in the shoot clusters and replace them by just one load balancer in the seed cluster. Okay, so are there any questions for the cost optimization plans? Otherwise, I would hand over, and thanks for your attention.
Thanks, Tim. So Svilen, you can take over.
So, can you hear me?
Yes.
Hello, everyone. Can you see my screen?
Yes.
So I'm going to quickly share with you part of the current progress on the control plane migration. The whole feature is still in progress, but just an update. With the control plane migration, we would like to achieve functionality that gives the ability of migrating the control plane of the shoot clusters to between seeds without affecting the shoot workload. And For that, we introduced a new API that is called ShootState. It is used to store the data required during the process of the migration. The data that is kept now is secrets and some valuable information for the extension controllers. And we create such a resource for every shoot, and we keep it next to the shoot resource, meaning it's in the project namespace in the Garden cluster. For the name, we are also using the shoot's name. And what do we store in it? Practically, one thing is the Gardener extension states. The idea is that every extension controller that requires to store some data in order to continue working properly after a migration has to save it into their extension resource in their status state field. And so during the extension controller reconciliation, if such state is not empty, we consider we are during process of migration, and the controller should know how to recover itself. And such an example is the provider extensions. Currently, they're storing the Terraform state config into the infrastructure resource, and during reconciliation, the extension providers are updating their status like here. So this is the infrastructure resource. After the infrastructure was created, the provider extension placed the data of the Terraform state in here. So, yeah. So in order to replicate this data in the Garden cluster, we've created this new controller. Currently, it is part of the Gardenlet, so that means it is running on the seed clusters. The controller is watching multiple extensions like the infrastructure, control plane, workers, and the extensions, and triggers when the shoot state, status state, I mean, of those resources is being changed. And if that change occurs, this controller replicates the data from the extension resource to the shoot state. Because of that, Gardenlet might be configured to be responsible of multiple seeds, not only the one that is running on. We made the controller to support multiple seeds as well. And this depends on the Gardenlet configuration. That means if you add new seed to the Gardenlet, that controller will dynamically start per seed. And in the end, the shoot state looks like this. This is just a small example. Here we can see that under the extensions in the spec, we persist for every extension resource, its kind, its name, and if it has a purpose, also the state that should be recovered during the migration. And that's simply it. Thanks.
Are there any questions to Svilen? Seems not to be the case. Are there any other topics you want to discuss today? Also not the case, so then bye-bye and see you next time.
Bye.
Yeah.